Hello my dear children, welcome to class 5 mathematics. Today we will study how to find LCM, that is lowest common multiple or least common multiple by prime factorization method. LCM by prime factorization method. Question: find the LCM of 48 and 72 using the prime factorization method. What is prime factorization? I hope all of you know. Expressing any number as a product of its prime factors called prime factorization, and here we will follow that method, and that is called as prime factorization method. Okay, let us understand. So first step, we know that we have to find all the factors to show 48 and 72 as a product of prime factors. That is called prime factorization, right? So we will first resolve 48 and 72 into products of prime factors. Okay. So I will write 48. All of you know how to find prime factorization. So I will write 48 and I will find the prime factors of 48 first. Then I will write 48 in prime factorization of 48 I will write. Okay. So I will draw two lines. Now next what to do? I will think of a smallest number, prime number, which can divide 48, right? So I will take the natural numbers. Think about the natural numbers. So natural numbers starts with 1. So 1 is not a prime number, right? Not a composite number. So next number is 2. And we know that 2 is a prime number, right? So whether 2 can divide 48, how to check? See, it is very simple. Just check the ones place digit. At ones place 8 is there, the digit is 8, right? So in the table of 2, 8 comes, right? That means 8 is divisible by 2. If the ones place digit is divisible by 2, then the number is also divisible by 2. How large the number is, that doesn't matter. If the ones place is divisible by 2, that means the whole number is divisible by 2. Here ones place is 8. 8 is divisible by 2. So 48 is also divisible by 2. So here we got the smallest prime number, that is 2, which can divide 48, right? So I'll write 48 and I will divide it by 2. Those who can do it in mind, that is very good. Those who don't know, please do like this. 2 2s are 4, right? Now subtract 0, then carry down 8. Now 2 4s are 8, right? Now we'll subtract 9. Remainder is 0. Now what is the quotient? Quotient is 24, right? Now we need to write the quotient below 48, right? So let's start. So I will take the smallest prime number, that is 2, and you can divide it directly also. Else you can divide in a divide it separately and write the quotient below 48. Else 2 2s are 4. In this way also you can do 2 2s are 4. Then 2 4s are 8, right? Now the next number is 24. Now we will think of, in the same way we will think of a smallest prime number which can divide 24, right? At the ones place we have 0. At ones place it is 4. So 4 is divisible by 2. So 24 is also divisible by 2. So I will take the smallest prime number, that is 2. Then I will divide. So 2 1s are 2. Then 2 2s are 4, right? Now the number is 12. Again same way, I will think about a smallest prime number which can divide 12. I know that 2 6 are 12, right? So I will take 2, then I will write 2 6 are 12. Now I will do the same thing. Think about a smallest prime number which can divide 6. Now we know that 2 3s are 6. Now 3 is a prime number, so obviously it will come in its table only. So 3 1s are 3, right? Let me erase this. Okay. Now I will take the next number, that is 72, right? In the same way I will solve this. So I will think about a smallest prime number which can divide 72. Here at ones place 2 is there. That means 72 is divisible by 2. So I will take 2 as divisor and I will divide 72 by 2. So divide it and write the quotient below 72. Right? Now next number is 36. 36 at ones place 6 is there. 6 is divisible by 2. That means 36 also divisible by 2. So I will take 2 as a divisor. Now 36 divided by 2, right? So 2 ones are 2, 1 left. Then now 1 6 16. So 2 8s are 16. You can divide it separately also. You can write the quotient over here. Now 18. So 2 9s are 18. It is very simple. Now 9 is here. So 9 and 2 cannot divide 9 because in the table of 2 9 is not there. So I will think about something else. Okay, some other prime number. After 2, next prime number is 3. So I will think whether 9 is divisible by 3 or not. Yes, we know 9 is divisible by 3 because in the table of 3, 9 comes. So 3 3s are 9. Now 3. So 3 1s are 3, right? Now we got the prime factors of 48 and here are the prime factors of 72. Now I will write 48 in prime factorization of 48, right? Now and next I will write prime factorization of 72. So prime factorization of 48 equals to, I will write the prime factors as a product, okay, multiplication in multiplication form. So how many 2's are here? 4 2's are here. So 2 multiply 2 multiply 2 multiply 2 4 times multiply by 3, right? This is the prime factorization of 48. Next number 72. So prime factorization of 72 equals to, again same thing. I'll write the prime factors of 72 in multiplication form. So 2 multiply by 2 multiply by 2 multiply by 3 multiply by 3. Done. So prime factorization of both the numbers we have written. Now next what to do? Right. So next we will find the common prime factors. Okay. In the prime factorization of 48 and prime factorization of 72. Here we can see 2 is there in both the prime factorization. 2 is the common prime factor in both the prime factorization, right? Now I will mark it. So next is we need to mark the common factors, right? First of all, we need to write the prime factorization of both the numbers. Next point, mark the common prime factors. Okay. Now next marked. Next also marked. Now is there any other common factor? Yes, 3 is here. So marked. Now we will write all the common factors, right? So common prime factors are 2, right? See, after this common factors, so first common factor, look at here. So 2 are common in both. So out of these 2 2's, we need to take only 1. Okay, we need to take the common factor only once. So out of this 2, I will take only one time 2, right? In the same way, next 2 also I will take one time. Next 2 also I will take one time. And next 3 also I will take only once, right? So common prime factors are 2, 2, 2, 3, right? Done. Common prime factors. Now let's think about the uncommon prime factors. So uncommon prime factors, what are the prime factors which are not common, right? So here 2 is not common and this 3 is also not common, right? So we will write that also. So uncommon prime factors are 2, 3. Correct? Now we need to find, what is our aim? To find LCM, right? So LCM equals to, it is very simple. LCM equals to product of all common prime factors. Product of all common prime factors, that means 2 multiplied by 2 multiplied by 2 multiplied by 3. That is called as product. After that multiplication, whatever you will get, that is the product. So product of all common prime factors, right, multiply by the product of uncommon prime factors. Okay, product of all uncommon prime factors. All. right? So product of common prime factors multiplied by product of all uncommon prime factors, that is equals to your LCM, right? So let's do it. So LCM equals to product of all common factors, right? Common prime factors. So what are the common prime factors over here? We have written 2, 2, 2, 3. That means 2 will come 3 times and 3 will come only once, right? So I have written all the common prime factors. Now I will write all the uncommon prime factors. Here we have only 2 uncommon prime factors, that is 2 and 3, right? So I will write that also. Now multiply them. After multiplying, the product is 144. And this is your required LCM, right? I hope this is clear to you all. Now I will write the answer statement. Answer, the LCM of 48 and 72 is 144. It's very easy. You do practice. Now let us find the LCM of 3 given numbers. Question: find the LCM of 27, 54 and 63 using the prime factorization method, right? So we know that we need to write the prime factorization of 27, 54 and 63, okay, as the method which we need to follow, that is prime factorization method. So we need to write the numbers in prime factorization, right? So first we resolve 27, 54 and 63 into the product of prime factors, right? So take 27, now draw 2 lines. Now we will think of a smallest prime number which can divide 27. We know that 27 is not divisible by 2. We need to think of the smallest number, right? So we will start from 2. So 2 is not a smallest prime number which can divide 27, right? Because at one's place 7 is there. So 7 is not in the table of 2. So not divisible by 2. So 27 is also not divisible by 2. Now we will think about the next number, prime number, that is 3. So is 3 can divide 27? Yes. In the table of 3, 27 is there. So 27 is divisible by 3. So now I will take 3 as divisor. Now 3 9s are 27. All of you know this. Now the number 9 is here. So I will think about a number. Think of a number which can divide, smallest prime number which can divide 9. So 3 3s are 9. Now next 3 1s are 3, right? So these are the prime factors of 27, right? Now next number 54. Same thing. Think of a smallest prime number which can divide 54. At one's place 4 is there. So 4 is divisible by 2. So 54 is also divisible by 2. So I will take 2 in divisor, right? Now I will divide 54 by 2. So 2 times 2. 2 2s are 4. So 5 minus 4 equals to 1. So 1, 4, 14. You can divide it mentally also. Those who can't, you can do it in rough work, okay? So I'll divide and write the quotient over here below 54, right? So quotient is 27. Now 27, we know that 3 can divide 27 and 3 is the smallest prime number which can divide 27. So 3 9s are 27. We have already done it here. Now 3 3s are 9 and 3 1s are 3. Until you get 1, you keep on dividing. I hope all of you know this in prime factorization, right? So you need to keep on dividing until you get 1 at the end, right? Now we will take, these are the prime factors of 54. Now we will take 63. Now we will think of, you have to think about a smallest, think of a smallest prime number which can divide 63, right? So 2 by 2, 63 is not divisible because at one's place 3 is there. Next prime number, that is 3. So whether 63 is divisible by 3, let's try. 3 2s are 6, right? 3 1s are 3. Yes, divisible. So 21 is the quotient. So I'll write quotient below 63, right? Now we know that 21 is divisible by 3. and 3 is the smallest prime number which can divide 21, right? So 3 sevens are 21. Now 7 has come and 7 is a prime number. We know this. So I will have to take 7 in the divisor. Prime numbers are divisible by themselves only or and by 1. So they are called as prime numbers. So 7 ones are 7, right? Draw a line and put 1. So 7 ones are 7. Now these are the prime factors of 63, right? Now I'll write the prime factorization of 27. As we are following prime factorization method, so I will have to write the prime factorization of each given number. So prime factorization of 27 equals to how much? See, what are the prime factors? 3 times 3. So I'll write 3 times 3 in multiplication form. 3 multiplied by 3 multiplied by 3, right? See, 3 multiplied by 3 multiplied by 3 is equals to 27, right? In this way, you can check it also. Next number, prime factorization of 54, right? Look at the prime factors and write it in multiplication form, right? So 2 multiplied by 3 multiplied by 3 multiplied by 3. Clear? Now next number is 63. So prime factorization of 63 equals to 3 multiplied by 3 multiplied by 7, right? Look at the prime factors. Now what step? Next step is to find. Please focus. Next step is to find the common factors, okay, in the prime factorization of 3 numbers, okay. Next step is to find the common factors in the prime factorization of 3 given numbers, right? We have written prime factorization of 3 given numbers. Now we will find the common factor, a factor which is common in all, right? Here we can see 3 is common in all, right? So mark it well. 3, 3, 3. Common, right? Now, is there any other common? Yes, 3, 3, 3 are there in all the prime factorization. So I will mark the 3, okay? Now we will take the common factors, prime factors, which are common at least in the prime factorization of 2 given numbers, right? See, 3 is here in the factorization of 27 and 3 is here in the prime factorization of 54, right? So this prime factor is common in the factorization of prime factorization of 2 given numbers, right? So we will mark the common factors, okay, which are present at least in the prime factorization of 2 given numbers. First of all, we have already marked the prime factors which are common in the prime factorization of 3 given numbers. Now we will mark the common prime number which are present in the prime factorization of 2 given numbers, right? So here mark 3 as well as 3. Now there is no common prime factor left over here. So we will start writing the common prime factors in 3. That is, here we have 3. So I will take this common only once, and next 3 also I will write only once, right? Now remaining common prime factors, that means common in 2 prime factorization, okay? So here we have 3 is common in 2 prime factorization. So these 3 also we will write. So first of all we will write the common in 3. Next we will write the common prime factor in the factorization of 2 given numbers, right? Now we will write the uncommon prime factor. So what are the uncommon prime factors? See, here we have 2 and 7. They don't have any common factor, right? So uncommon prime factors equals to 2, 7, right? So how to find LCM? LCM is the product of all common prime factors, then multiply by the common prime factors in 2 given numbers, then the uncommon prime factors. We need to multiply them all. So, product of all common prime factors of all numbers, then multiply by product of remaining common factors, that means common factors which are in two given numbers, in the factorization of two given numbers, then multiply by the product of uncommon prime factors, right? So, product of all is your LCM. Correct? Let's do it. So, LCM is equals to, what are the common prime factors? 3, 3. So, 2 times 3 will come. Then, the common in two common factors present in the factorization of two given numbers, that is 3, right? So, I will write 3 multiply by 3 multiply by 3. Then, the uncommon one, that is 2 multiply by 7, right? Multiply them all. You will get the product equals to 378, and this is your required LCM, right? So, answer, the LCM of 27, 54 and 63 is 378. I hope this is clear to you all. Do lots of practice. Okay? Solve many questions to have a good hold on this. Thank you.